Okay, it says a neighborhood recreation. Ooh, this is a good one. This is right off the ACT, one of the problems. So this is what we just learned. So it says a neighborhood recreation program serves a total of 280 children who are either 11 years old or 12 years old. The sum of the children's age is 3,238 years.
Wow.
How many 11-year-old children does the recreation program serve? So this is just like setting up an inequality. Remember we just did this? Okay. So first of all, with these kind of problems, I always say to myself, I have two variables. One is 12-year-old boys, right? 12 years, we have no idea how many 12-year-olds, and my other one's 11-year-old. So that's always how I start out. Otherwise, it's really hard to set up an equation. Do you understand that? Okay. So it says, the neighborhood recreation program serves a total of 280 children. So if we have this many children plus this many children, it equals 280, right? So x plus y will equal 280. So x plus y will equal 280. And it says the sum of the children's age is 3,238 years old. So if you think about it, 12 times x, the number of people that are 12 years old, right?
Yeah.
Plus 11 times y will equal 3,238. Now let's just set up a matrix and solve it using our graphing calculator. 10 times quicker than solving it by hand, right? And then we're doing that. So that would be 280, right? 12, 11, and 3,238. So you'll have to remember how to do it on your calculator, though. So remember, it's matrix, or you go second matrix. Do you guys have a calculator with you? Because it takes a little practice to remember how to do it. So you have to do second matrix into edit. You guys need a calculator. Because it takes a second to remember. You gotta put in what kind of matrix. So it's a 2 by 3, 2 by 3, and then 1 enter, 280 enter, 12 enter, 11 enter, and 3,238 enter. Then you have to hit second quit. Then you have to go back into matrix, math, and then reduce row echelon form. And so you get, did you say error? Did it say error for you?
No.
What did it say?
158, or x equals 158.
X equals 158, and X was 12-year-old boys, or girls, boys or girls. And then Y is 122. So guess how many 11-year-olds we have? 122. Okay. So we were going for like 11-year-olds, right? So awesome. So not that bad, but we probably wouldn't have been able to do it without what we just learned in secondary three. Okay. Okay, so this one is actually quite simple, but a lot of people probably wouldn't get it right. It says a geometric figure shown below consists of a square and 4 semicircles. So they gave this picture, but exactly like this. It says the diameter of the semicircle are the sides of the square. So you can see that, right? Diameter of the circle are the sides of the square. It says each diameter is 10 centimeters long. Remember, if they give you something, you probably need to use it. So we know from here to here is 10. From here to here is 10. Once again, 10 and 10. Okay. Now it says, which of the following is the closest approximation of the total area in the square in square centimeters? So it's like, what's this whole area? So we've got to calculate area in sections. Let's calculate the area of a square first of all. So area of a square is length times width, right? So our area of the square part is going to be 10 times 10. Okay, area of 100. So we know we have 100, but then we have to find the area of each circle, right? It's a semicircle. So if you put these two together, wouldn't that make one circle?
Yes.
Okay, right here's one circle, and right here's one circle. So we have 2 circles, right? So we find the area of one circle and add it up twice will be good, right? So you would have to know this for the ACT. The formula to find the area of a circle is pi r squared. So area is equal to pi times the radius squared. What's my radius? Careful, don't do diameter. 5, right?
Yes.
5 squared. So we have area of that is, and since it says, and it looks like they're not putting their answers in pi, so we're gonna type that in. 78.5. Okay, so we have 2 of those. So add it up. 78.5 for that circle.
57.
And then so you add that up twice, and then 100. You got 2 what?
257.
257, so the closest to the area would be this one. Does that make sense?
Does it have to be exact, or is it?
Well, it says right here, which of the following, these are the exact answers on the test. It says, which of the following is the closest approximation? Is there any answer even close?
Yeah.
No, this is the only one that's close, right? There's no other answer even close. You would go with the closest. Does that make sense? Okay. Sweet. Okay, next one. My picture's hideous. Just keep in mind, on the ACT, this was all evenly split up. So, like, this is actually right down the middle. Okay? My drawing's it's hard to draw by hand. So it says, which of the following expressions is the closest approximation to the height h in feet of the roof trusses shown below? So I actually sat and like looked at this one for a while, and I'm like, and then I finally realized I'm making this much harder than it is. So first of all, if this picture is evenly split, we know from here to here is 15 feet. And in the picture, it's much better than mine. Mine doesn't look evenly split. So sorry. So that's 15 feet, that's 15 feet right there, okay? And then we are trying to find the height and height. So we know we're definitely dealing with triangles, right? So we have this being dropped down, and from their answers, I was pretty safe to assume, well, I knew from the answers that they are assuming we're dealing with right triangles. So we know we have right triangles. Otherwise, I wouldn't ever assume it's a right triangle. Because this right triangle trig is sine, cosine, tangent.
Attention students, to take the speaker's bus. Your bus is a little bit late, so be patient. Again, those students taking the speaker's
Right
bus,
triangle trig.
your bus is going to be a little bit late, so be patient.
So I'm like, okay, so we know we have a right triangle right here, and I thought about it, and I'm like, if we have a building built and we drop down this, it better be 90 degrees in the building, but I don't ever assume it's 90 degrees unless told. But then I looked at the answers, I'm like, we are assuming it's 90 degrees. Okay, is everybody okay with that? So don't we just have a right triangle? And then we know that this length from here to here is 15, and then this is 20 degrees, we're trying to find h, right? So then this is secondary 2 stuff, so it's right triangle, trigonometry. So we've been learning in secondary 3 all non-right triangle trig. In secondary 2, you learn right triangle trig. So we have angle theta, right? We're given the opposite and the adjacent side from that. So opposite and adjacent. We did talk about it briefly. You'll have to know this. You need to know this for your ACT. Sine, cosine, tangent, yeah, SOHCAHTOA. And then I do the little saying, which SOHCAHTOA is the same thing. Oh, heck, another hour of agony. So we have the opposite from theta and the adjacent side from theta. So we'll use tangent, right? So we have tangent of theta, but our theta is 20, right? Tangent of 20 is equal to opposite, which is h, over adjacent, which is 15. Now it's just algebra to solve for h, right? So when we multiply both sides by 15, so then look, boom, 15 tangent of 20. H is the height. So the answer is, hypotenuse, which is always across from the 90 degrees.
Okay.
Yeah. Opposite, adjacent, and hypotenuse, yeah. So you'll have to remember your secondary math too. Because in most ACTs, they'll put a right triangle trig question and a non-right triangle trig question, like what we've been learning. They usually will have one. Okay, questions on that. So that one was pretty easy, right? Okay. Okay, so it says, this one I actually haven't gone through myself. So let's go through it. It looks a lot harder than it is. Remember how all those problems look a lot harder than they are. So first of all, I really hope that you learned a lot in secondary too. So it says, in the figure, line M and line N are parallel. Oh, this is line, it says N and M. Okay. On the ACT it said that. Okay, so it says line N and M are parallel. So we have these two parallel lines, and it says which of the answer choices does not necessarily add up to 180 degrees. So you really have to know your secondary 2 stuff. Okay, so first of all, I'm going to do this one by the process of elimination. Does angle A, angle B, and angle F add up to be 180 degrees? Do I know for sure? So let's look at this first one. Angle A plus angle B plus angle F. So what you're going to have to know is...
If angle is... Yeah.
Okay, I'm going to come back to that one. Okay, let's go on to angle A and B. A and D, those will add up to be 90 degrees because they are okay, here's why. This angle is equal to this angle.
Yeah.
And this angle is equal to this angle. That angle, but we know this angle is equal to this angle, so this plus this must be 180, right? Doesn't this make a straight line?
Yeah.
So we know for sure that one is 180. Does that make sense? This angle is equal to this angle, so this angle plus this angle we know definitely adds up to be 180. Okay. So we cross that one out. Let's do angle B, angle EF. Let's try that one. BEF. Oh, we know that one for sure adds up to be 180, right? So we're eliminating our answers here. Angle D and angle E. Oh, definitely, right? That was the same as ABE, right? Don't those add up to be 180? Aren't they straight line angles? Which that brings us back to this. That's why this one didn't work. Because we know angle A and angle E are alternate interior angles, so they're equal. Okay, so we're almost down to the end here. Angle E and G. Okay. E and G, do they add up to be 180? E and G.
It's like it's the same, G and E are the same.
Not necessarily,
No.
because those don't, because here's the thing, a lot of students will assume that because they'll look at these as parallel lines, but they're not parallel. So we can't assume that, but let's kind of think through this one.
Yeah, it's B and F.
E and just up like this.
The other.
Okay, just a second. Come on. Okay, this is, okay, so angle A, B, and F. Okay, let's see. A, B. Oh, yes! Okay, I see it now. Okay, A, B, and F. Okay, so we do know for a fact. F and C are equal, right?
Oh.
So we do know that this one equals 180. Good.
That was.
Okay, yay! Okay, good. So we know that this is the only one that doesn't equal 180.
You got
Okay,
so excited.
I know. You're right.
That kind of scared me.
I'm like, yes! Okay. Does that make sense, everybody?
Yeah.
Okay. Awesome. All right, so, I mean, honestly, guys, you know, like, let's say you were able to eliminate these three and you were guessing between these. At least it's 50-50 rather than whatever, but hopefully you'll get even better than that. Okay, so next one, it says, Annette took 10 minutes to walk around a rectangle. You guys, secondary 2 is such a huge thing of the ACT. I really hope you guys learn here. Okay, so it says, Annette took 10 minutes to walk around a rectangular field. The length of the field is 4 times the width. How long would it take Annette to walk the width of the field? So I'm like going to go through and kind of draw my own little picture here. I have a rectangular field. It says Annette took 10 minutes to walk around the rectangular field, okay? So the whole perimeter is 10, right? So perimeter is 10. It says the length of the field is 4 times the width. So we have no idea what the width is, right? So let's call the width x, right? But we do know the length is 4 times that amount. 4x, good. So now it says how long would it take Annette to walk the width of the field?
Wait, the width is 4x, right?
Right.
Wait,
No,
that's
it's
x.
no, the length is 4 times the width. So 4x.
Oh,
4 times the width. Yeah. Yeah.
That.
No, you're good. So then we know if this is x, this is x, this is 4x, right? So adding up the perimeter will equal 10. Solve for x, right?
Yeah.
Okay, so we have 4x plus 4x plus x plus x is equal to 10. So that's 8, 9, 10x, right? So 10x is equal to 10. What's x? X is equal to 1, but make sure you're asking the right question. It says, how long would it take Annette to walk the width? So width is this one, right? So it would be 1. But what if they said it'd be 4, right, everybody? Length is 1. Did that confuse you?
It took me a minute, but I got you.
Okay. So if it said this, and I've seen this before, if they said the length was 4 greater than the width, that's 4 plus, x plus 4, right? Make sure you know the difference between 4 times and then 4 greater than or less than. Does that make sense, everybody? Okay. Okay, next one. It says, what's the slope of the line in the graph? So, I mean, slope's pretty easy, but you can do it 10 different ways. Rise over run's one way. So what's our change in y? 6, right? What's our change in x? 3. What is that? 2. That's one way of doing it. Isn't that the probably easiest way, right? Change in y, rise over run. But was it negative? Yeah. See, we just messed it up and missed it on the ACT. Shame on us. Shame on me. It's a negative slope, right?
Yeah.
So it would have been negative 2. Okay, so we could have done that, or we could have done, oh, I know the equation of slope of a line, which is y2 minus y1 over x2 x2 minus x1, right? You know that's the equation for slope. So this is xy, this is xy. Your first point is the one that comes to the, it's looking like a book. That's our first point, our second point. So y2 would be 0 minus 6 over x2 is 3 minus 0, right? Negative 6 over 3, which is negative 2. Do you see how to do it both ways? Just be careful, because see, this way I like got a little hasty and didn't pay attention to the fact that it was
So
negative.
if it doesn't show us a picture, you see equation.
Yeah, or you could kind of like draw your own picture.
I mean, even if you like drew your picture.
Even if you drew your picture, you could get it wrong. You know what I mean? It's like I said, where you're just looking, eyeballing it, you might miss something. This, it's always going to come out. Okay, so just pay attention. Okay, so we can stop there. Thanks for coming.